Hello guys, welcome back to my channel. Today we'll be talking about angle of elevation and depression in mathematics. Okay, but what's angle of elevation and depression? For instance, a person stands and looks up at an object. The angle of elevation is the angle between the horizontal line of sight and the object. Or if a person stands and looks down at an object, the angle of depression is the angle between the horizontal line of sight and the object. What this is trying to say is that, okay, let's bring it to reality. For example, let me say you are in your house, you're in your compound, and you're looking at your horizontal line. So the angle in which you decide to lift your sight up, maybe to look at a bird in a tree or to look at a tree itself, is the angle of elevation. The angle in which you leave your horizontal line and elevate towards the tree, that's the angle of elevation. Or when it comes to angle of depression, it's similar to that of angle of elevation. Is when you decide to change your sight, like from your horizontal line, you decide to drift down, maybe to pick a pen, or maybe to look down, maybe at something below. So the angle in which you drift your eye by moving down, or you shift your sight, that's the angle of depression. So today we'll be talking about how to solve word problems on angle of elevation and depression. Okay, so when it comes to solving angle of elevation and depression, there are formulas which are very vital, and the well-known formula for solving angle of elevation and depression is a formula we call SOH CAH TOA. SOH CAH TOA. Yeah, this is it. So firstly, what is SOH CAH TOA? You've heard about sine, cosine, and tan, or you say tangent. Okay, so how do you know when to use this? Okay, this is representing sine, which is opposite, which is opposite over the hypotenuse, while this is representing cosine, or you call it CAH, which is represent adjacent over our hypotenuse, and this is our tan, which is representing opposite over adjacent. Yeah, okay, but before we move into solving some problems on word problems on angle of elevation and depression, I would love to illustrate this a little bit more, so we'll understand and get more familiar with what we are working about. Okay, remember I said that the angle of elevation is the angle which once I drift from the horizontal line and looks upwards. That's the angle of elevation, and that of depression is similar to that of elevation, where it's like the opposite way around. When you look from your horizontal line and you decide to drift downwards, that's your angle of depression. So by the end of today's lesson, you'll be able to differentiate between angle of elevation and angle of depression. So let me demonstrate this, for example. Okay, so let me say, supposing this is your horizontal ground which you stand on. Yes, and maybe this is a tree. This is a tree, yeah, a tree. Okay, this is a tree, and maybe you just came out from your house, maybe to take a view. So yeah, let's assume this is you. So yeah, so this is your angle of sight. This is where you horizontally focus when looking at the tree first. Then maybe you saw a bird in the tree, I saw a bird in the tree, so you're like, let me look at this bird first. I'm not really good at drawing. Okay, bird in the tree, then you decide to look upwards toward that bird. Okay, let me say, you need to look upwards towards the bird. So the angle in which you decide to lift your eyes from the horizontal line towards this area is your angle of elevation. Yes, so that goes the same for depression, but let me use another scenario. Yes, so here we go. So let's use a different context to describe this. Okay, let's assume that you're in a hill, on top of a hill. Yeah, so this is a hill, and maybe this is where you are. Yes, this is where you are. I'm just making it so you won't fall down. I'm just help you. So okay, this is where you are in the hill, and let's assuming this is a tree or a pole. I'm just use a pole this time. A pole. Maybe your brother is down the pole here, and maybe like looking at, maybe there's okay, I'm saying maybe there is something interesting you find here, and this is your horizontal lane. You're focusing on that, and maybe your brother just came and asked, maybe Calvin, mom is calling you, and you decide to drift. Your eyes drifted and focuses on your brother, for instance. Focus on your brother. So the angle in which you left your horizontal lane, like your horizontal focus, and look down, is your angle of depression. Yeah, that's your angle of depression. Okay. Alright. Okay, so let's try this with some word problem. Okay, let's take a look at this question. It says a man 25 meters tall observed the angle of elevation of the top of a pole 20 meters away is 25 degrees. Find the height of the pole. Okay, it says a man 25 meters tall. Let's take this into a diagram form. Okay, let's assume this is the man. Okay, let's make a horizontal ground, because he cannot be standing on the air. Okay, so assume this is the man here. Okay, so here is the man. So his height is 25 meters tall. Okay, 25 meters, that's his height. Okay, say a man 25 meters tall observes the angle of elevation of the top of a pole 20 meters away. So let's just illustrate this. So this is the pole, which is 20 meters away from the man. So the distance is 20 meters away. Okay, so firstly let's assume he is looking at the pole horizontally. Then he decides to look up, because it says observe the angle of elevation of the top of a pole 20 meters away. So let's give the angle of elevation. Good. So here's the angle of elevation where he decides to drift from his horizontal lane upwards. So it says the angle of elevation is 25 degree. So put out 25 degree here. Okay, so we good. Alright, so and that says we should find the height of the pole. Okay, we are going to find here, which is x. But there's more. So we have to find here, which is x. Okay, there's a better way we could do this first. First, we're looking at this. But looking at this height, you see the man is 25 meters already. That means from his horizontal lane to the ground should be 25 meters of the pole, meaning that this part of the pole is also 25. So what we have to do, we just have to find here to here. Then we add it up with 25 meters, which is also the height of the man, to get the total height of the pole. Okay, first let me bring this down first, so we could work more in context. So let's bring it down. Okay, so let me say this is it. Okay, This time this is a man from his point of view. Which was that point of view, yes. So this is the pole. Remember, we still have a missing 25 meter over here, because from here to here is 25. Okay, let's continue. So we have it says that the question says the distance is 20 meter, so here's going to be 20 meter. Okay, and we asked to find the height of the pole, which is here, so here's going to be x. So okay, we're going to use our humble formula SOH CAH TOA. That's what I call it, SOH CAH TOA. So we're going to use SOH CAH TOA to solve for this. So okay, but how do we know which formula to use? How do we know? Because sometimes even I to do my time, I did find this difficult to ascertain. Okay, but let's take a look. So when you see you're dealing with two sides. Okay, I didn't label it. Sorry, I could have said this earlier in the part of the video, but I'll be putting them down in my description below. I'll be describing all the parts of the right angle triangle. So I didn't say this, but here is the hypotenuse, which is always the longest part of the triangle. So here, right here, is going to be our opposite, because this is the place that the man was looking at. Anyway, the angle faces, any of this angle faces here, it's going to be opposite. If it's your angle was here, here becomes the opposite. But here always becomes the hypotenuse. It never changes, because the hypotenuse is the longest part of a right angle triangle. So once your angle is here, it becomes the opposite. Here's the opposite, and adjacent doesn't have a permanent position. They varies based on where the angle faces. So let's continue. So continue with this. We're going to look for a formula that has to do with the opposite and adjacent, because that's are the two things we're looking for. Here's our opposite and here's our adjacent. We don't have any business with the hypotenuse, because they did ask us to find maybe the height by which is he looks at the angle. Has to find the height of the pole. So let's proceed. So which formula here has to do with, I recently explained this is the opposite of hypotenuse, this is the adjacent of hypotenuse, and the opposite of adjacent. So when you looking at this diagram, you can see that we're dealing with opposite and adjacent, because those are the things we are working with. So we are going to use the formula tan. So that's the formula, which is tan theta equals opposite over adjacent. Okay, let's proceed. Alright, so remember it says that the angle is 25. Let me just check it again. Yeah, 25 degrees, so this is 25. So we have tan theta is, in this case theta is 25, so we say tan 25 equals to the opposite, which is x we have here, and the adjacent, which is 20 meters. So we have tan 25. So we're going to use our calculator to find what's tan 25. So tan 25 here is going to give us 0.4663. So we have 0.4663 equals x over 20. So what we're going to do is we're going to cross multiply. X times 1 is x, so 0.4663 times 20. 0.4663 times 20. We're having 9.326. 9.326 but let's round it off to 9.3. 9.3, so let's round it out to 9.3. Alright, so the height of the, remember that we knew have the height of the pole, or so let me just say part of the height of the pole, which is also equivalent to the height of the man, which is 25 meters. So we're gonna add the 25 so we're gonna add the 25 meter. I think yes, we're gonna add 25 meter. Okay, so we're gonna add the 25 meter, which is height of the man, which is equivalent to part of the height of the pole plus the remaining height of the pole. So we have 25 here plus 9 plus 3, which would give us 25 plus 9.3. So we're having 34.3. That's just we're having 34.3. This is the height of the complete height of the pole. So let me just redraw the diagram again to demonstrate how we got here. So okay, so let me just redraw the diagram. Okay, remember this is the ground. Okay, this is the pole. This is the pole. Okay, this is the pole. Okay, let's assume this is the man. This is a man, which is 25 meters tall. So this is the point, his horizontal view, where he looks forward before he observes the height of the pole at the angle 25 degree. Okay, so let's proceed. So we know part of the height of the pole, which is equivalent to the height of the man, is 25 meters tall. Then we got our new height, which is 9.3 meters tall. So when you sum them together, you have a total height of 34.3 meters is the height of the pole. Okay, let's try another question on this. Alright, let's take a look at this question. It says an erected electric pole is 7 meters high from the ground. It casts a shadow on the horizontal ground when the altitude of the sun is 60 degrees. Calculate the length of the shadow. Okay, so let's assume this is the ground. Okay, then this is the electric pole. This is the electric pole. Okay, and it says that electric pole, it's 7 meters high, so 7 meters high. Okay, and it's cast a shadow on the horizontal length. So this is the shadow here. Yeah, this is the shadow of the pole. The shadow, and it says cast a shadow on the horizontal ground when the altitude of the sun is 60 degrees. Okay, here's the altitude of the sun, which is 60 degrees. Yes. Okay, so let's proceed. So we asked to find what calculate the length of the shadow. So from here, so here is the length of the shadow. That's from the pole here, which we're going to label x. Which we're going to label x is the length of the shadow. Okay, so we're going to use our formula, which is the SOH CAH TOA. Let me just try it here again. So before we work for this, we are okay. Here is a hypotenuse again. Don't worry, I'll be describing all of this in my description, so please, for all viewers, make sure to check the description so you could understand more on the topic, because I'll be doing a lot of explanation on the description. Okay, so we're looking for a formula that has to do with the, okay, let me just write here. So now in this question, here becomes our opposite, because the angle here is actually facing towards this side, so here becomes our opposite, and that leaves us with 7 meters, which is our adjacent. Okay, so let's proceed. Okay, so we're looking for a formula that has to do with adjacent and opposite. So it's tan, so tan theta which is equals to opposite over adjacent. Okay, so we our tan theta here is 60 degrees, so tan 60 equals to opposite, which is our x, over our adjacent, which is 7. Okay, tan 60 tan 60 is 1.7321. So we say 1.73, okay, 21. At 1.7321, okay, equals to x over 7. So we cross multiply. So these are x over 7. So we find x times 1 is x, so x equals to, so 1.7321 times 7 is giving us 12.1247. But let's run it out to 12.12. 12.12. Okay, so 12.12 is the distance or the length of the shadow. Yes, the length of the shadow. So 12.12 is our length of the shadow. So 12.12 is our length of the shadow. Okay, let's take a look at this. It says a surveyor walks 500 meters up a hill which slopes at an angle 30 degrees. Calculate the vertical height through which he rises. A surveyor walks 500 meters up a hill. So let's just draw a hill. So let's assume this is our hill. Assuming this is our hill, and our hill looks like so. This is our hill, and this is the surveyor. He's walking. He walked 500 meters up the hill, so that means here, so that means from here to here is going to be 500 meters. Okay, so he walks 500 meters up a hill which slopes at an angle 30 degrees. So from the horizontal ground to by which he elevates, by which he rises, is going to be 30 degrees. So it's going to be 30 degrees. Okay. So That's the equation which calculates the vertical height through which it rises. So we're asked to find the vertical height, which is here. So we're asked to find the vertical height through which it rises, which is here. Here. So we're asked to find here, which is our x this time. Okay, let's go further. So you're looking for, we'll use our formula again. So okay, so let's go further. Okay, this is our opposite. This is our hypotenuse, which always remains the longest part of a triangle, and here is our adjacent. Yes. Okay, so we're looking for a formula among all this that has to do with the opposite and the hypotenuse. Opposite and hypotenuse. So that is our sine here. Okay. So sine theta equals opposite over the hypotenuse. Yeah. Okay. Let's continue. So sine theta here, so our sine theta is going to be sine 30. So we have sine 30, which is equals to the opposite, which is x, over our hypotenuse, which is 500 meter. Okay. So we have this 500 meters. We have sine 30 sine 30 is 0.5, so we have 0.5 equals to x over 500. So we cross multiply. So we have x equals to, or equals 0.5 times 500 is 250. So our x in this case is 250. So 250 is the vertical height through which he rises. Okay. Now what? Let's try one more question before we close for the day. Let's try one more question. Alright, so here's another one. It says the angle of depression of a boat from the top of a cliff 10 meter high is 30 degrees. How far is the boat from the foot of the cliff? Okay, so let's draw the cliff. So we're going to illustrate we're going to illustrate this question with diagram. So assuming that this is the cliff, for example. Yes, this is the cliff, and this is the ground. Though we know boats are not normally on the ground. So this is the cliff, this is the ground. So assuming this is the boat here, let's assume this is the boat. Okay, so we have this like this, angle of depression. So now this is the angle of depression by which the angle of depression of a boat on the top of a cliff 10 meter high is 30 degrees. How far is the boat from the top of the cliff? So the angle of depression is 30 degrees, and it says that how far is the boat from the foot of the cliff? Okay, firstly, the angle of depression of the boat from the top of the cliff. The angle of depression of a boat from the top of a cliff 10 meter high is 30 degrees. That means the cliff is 10 meter high. So here it becomes 10 because it's 10 meter high. Okay. So we asked to find the distance. I think so. Okay. So how far? So actually asks us how far is the boat from the foot of the cliff. So from the foot of the cliff, which is here, we're actually looking for this. So I'll just label it X. So I'll just label it X. Okay, so let's continue. We are going to use our formula, the SOH CAH TOA. Here, I'm just right here. Okay, let's continue. So we're going to look for a formula that has to do with, this is the hypotenuse. Then this is our opposite. Good. Alright. So this is the adjacent. Okay, so we're looking for a formula that deals with the adjacent and opposite because that's what we are working with. You have no business with the hypotenuse. So adjacent and opposite look like it's our tan. So we're dealing with tan, so we'll use this formula here. So we are using with tan, so we'll say tan theta equals tan theta equals opposite over adjacent. So our tan theta here is tan 30, which equals to opposite, which is x, over adjacent, which is 10. Okay, so tan 30 is 0.5774 equals x over 10. So we'll cross multiply. So we have x equals to 0.5774 times 10. Which is 5.774, but let's round it up to 5.8. So we have 5.8. So 5.8 is the distance, or we say is how far is the boat from the foot of the cliff. Or you could just call it a distance too, it's the same thing. Alright, so we've come to the end of today's lesson. I hope you find it interesting and I hope we had fun together. So please, if this is your first time watching and you've not subscribed, please make sure to do so. And if you have any question on dealing with angle of elevation and depression, please let me know in the comment section below. And also please don't forget to give this video a like, and thanks for watching.